right, here's the last example that we needed to get to for our notes. So make sure you get this in your notebook. I want you to solve this equation for x, and I want you to notice that the x is your exponent. Okay, so this is to the first power. The 9 has a power of 2x plus 3. When you are solving a problem like this, you want both of your base numbers here to be the same, and these are not the same at all. So the first job we need to do is make sure our base numbers match. All right, so your base numbers must match. So that might require a bit of work. So we might be able to keep it as a 9. The only other way to write a 9 is as 3 squared. So we can only use a base number of 9 or a base number of 3 to represent this number. So we need to see what we can do with that 2,187. So you've got some calculator work to do here. Now if you add up all your digits, I notice they add up to 18. Dividing by 9, if all of your digits add up to something 9 will go into, you can divide by 9. So if you take your calculator and divide that by 9, you get 243. Okay, now I notice that I add these digits up, and I can divide by 9 because these add up to 9 itself. So I know I can divide this number by 9. So if I take a calculator and do that, I get 9 times 27. So far I'm in pretty good shape with using a base number of 9 to represent this number here. Because I notice the 27 can be divided by 9, but then it's 9 times 3. I cannot get another 9. So what I need to do is go back and see how these can be broken down further. I've got a 3 here, and each of these 9s can be turned into 3s. 3 times 3 here. 3 times 3 for that 9, and we've got this one up here. 3 times 3. We've got all 3s in our factor tree. 1, 2, 3, 4, 5, 6, 7. We could rewrite this number here as 3 to the 7th power. Our base number of 9 didn't work because we could not get all 9s. So we had to go further. We could get all 3s at the end of our factor tree. So that means I need to use a base number of 9 here, of 3. So I'm going to take that 9 away. I'm going to keep my power. I'm going to rewrite my 9 using a base number of 3 and write it as 3 to the 2nd power. So we need to clean up our exponent. We are going to use the exponent rule where we multiply our powers. So if we take, keeping the 3, if we take this 2 and multiply it by this exponent here, it's kind of like the distributive property, you're ending up with 4x plus 6 as your new power. And we'll bring down the 3 to the 7th power. The reason why you want both your base numbers to match is because once you have equal base numbers, if you know both sides have the same value, you know you must have equal powers. That is all you need for your equation now to solve for x. We know that this power must equal that power, so the 4x plus 6 must also be a power of 7. This has to be 3 to the 7th power to match this right here. So when we solve that, we get 4x equals 1, divide by 4, and x equals 1/4. And that's what they wanted you to figure out. What would the value of x be for these two sides to match? The key is make sure both of your base numbers are going to be the same. So you need to figure out what base number to use. It's easier to focus on your smaller base number to see how it can be rewritten, and then use one of those to help you rewrite this value here. Once you get your base numbers to match, clean up your exponents using the power rule. Don't forget, when I multiplied by 2, because I had 2 terms here, I had to multiply them both by 2 to get my new exponent. Once your base numbers are the same, all you have to do is determine what x is to make your exponents equal. So set those equal and solve. Okay, and we'll go over that more when I see you next.